Shelley.
Join Dr. Coffee Brown to discuss what's new in health and medicine. Dr. Brown and his guests explore the latest research and technology in health and medicine and help us understand how it affects our lives. Then they provide takeaways and steps we can take to improve our own health and the health of our planet in the future. We're glad you're here to take part in the conversation.
Shelley.
In this episode, Dr. Coffee Brown's guest is Timothy J. Ross, Ph.D., professor of civil, electrical, and computer engineering, and award-winning author of Fuzzy Logic and Probability Applications. Dr. Brown and Dr. Ross will discuss the viability, pros, and cons of bamboo as a sustainable engineering and architectural material. Thanks for joining us today, and now back to our host, Dr. Coffee Brown.
Hi, thanks for joining us tonight. I have been fortunate enough to know Professor Ross from some committees and things that we've been on at the university. He's a super interesting guy to talk to. But I have to say, Dr. Ross, when I was looking at your resume preparing for tonight, I was kind of stunned by how many different areas of expertise that you have. You've been a pretty busy guy for a while. He is now, by the way, a distinguished professor emeritus. I am also emeritus, but I'm much lower ranked than that. And so, I mean, here's a guy with a really deep and rich background. And I've been fascinated separately, even before we began talking about it, by bamboo for a lot of virtues that it has, which we're going to explore tonight. And bamboo, some kinds of bamboo, grow very well in our area. Others, and this is one of the things I'd like to touch on, may have trouble with our part of the country because of the occasional freezes that we get. I do want to make one passing tangent, and that is this Wednesday at 7 p.m., New Mexicans for Science and Reason, and their website will be posted here, is having a panel discussion on ivermectin for COVID. This has become the latest hydroxychloroquine. And you need to know, what are the pros and cons? Why are some people pushing it? Why are folks taking livestock dewormer rather than getting vaccinated? And there turns out to be more to that story than I would have guessed. It's a little more complex than the hydroxychloroquine story. So with all that said, Dr. Ross, back to you. Tell us a little bit about what got you interested in bamboo from an engineering perspective.
Well, it was sort of a coincidence. I'd been going to Brazil for a number of years in the early part of this century for another reason. Because of my work in the use of fuzzy logic to capture linguistic uncertainty in databases, I went down to Brazil a couple of times each year to teach groups of scientists on how to use that technology. And on one of my trips, I had some extra time. This was in 2012. So I had a colleague who teaches at the University of New Mexico who is Brazilian, and he actually went to this university in Rio de Janeiro. It's simply called the Catholic University. And he had colleagues there. And I said, geez, you think I could get a tour of the civil engineering department and laboratories, because I am a civil engineer? And he said, sure, I can line you up. So I got down there, and the first person that came up to introduce himself to me knew my name and knew me. It turns out we were classmates at Stanford way back in the late 70s. And I was just completely floored that he had known me, and I felt like I was coming home or something. And
I knew you before I knew you too. When your textbook on fuzzy logic came out, the first one, I was aware of that. It got some press at the time, and I was interested in in nonlinear, non-absolute logic at the time because I thought computers were too limited in what they were doing. And your book hit right at the time that I was mulling that over. That is not to say I understood your work, but I got the gist of it. I had the general
Yeah.
shape of it. And so I actually did not have any idea then that I would meet you many years later, but I was aware of your work then.
Okay. Well, this fella, his name's Raul. He of course knew me, and he did give me a tour of the facilities. And in one of the facilities was a bamboo laboratory led by an Iranian professor named Khosrow Ghavami. He's a world's expert on the use of bamboo in mostly structural applications. And I was just amazed at what bamboo could do. I was amazed at the strength properties. I'd known a little bit about how strong bamboo was, but I did not know the breadth of the interest in bamboo, especially from environmental concerns. It's used in so many products, from clothing to food additives. The list is quite long. And so he showed me a little bit about what he was doing with bamboo. It was small things like bicycles made of bamboo and cabinets. And I started looking into this, and this material is just amazing. It's 3 times stronger than wood. The economic impact of this is that it grows 35 times faster than wood. Can you imagine?
It's a grass.
It's a grass, and it's not a tree. So you could get 30 times as much bamboo in the same amount of time as you can from lumber, to use lumber to build wood buildings. And I asked him the question, well, why aren't more places in the world using bamboo? And he said, well, probably a few reasons, like it's not available all throughout the world, but we've got exports. We can export mangoes to the United States.
Familiarity and expectations drive a lot of what people do.
Yeah.
We often don't innovate simply because we're used to what we've been doing.
That's right. So, but the biggest technical reason why people hadn't been using bamboo in buildings is because of the connections. Bamboo is round like this. This is a half of a piece of bamboo. This is about a 5-inch piece. And let me see if I can get the camera on this. This is a piece of bamboo that is extremely hard, and it's 5-inch diameter, but it's almost an inch in diameter. The main comb that goes around, these little diaphragms in the middle actually provide this specimen with stability and strength against buckling. But the center is largely air, so it's lighter than wood per unit volume. And as I said, it grows 35 times faster than wood. And as you mentioned, it's a grass, not a tree. So when you cut the bamboo down, it doesn't die. The roots, just another stalk just pops right up. When you cut a tree down, the roots also die. And then you lose stability in the soil, and especially on steep slopes, you'll get mudslides. So in California, it's a cycle. There's a forest fire, kills the trees, then the roots die, then you get heavy rains, and then you get mudslides. And it's a big cycle every year.
Thinking of that, are bamboo forests any more or less vulnerable to fire than tree forests?
No, it turns out bamboo burns just as well as wood does. So there's no advantage or disadvantage. The advantage is that if it does burn, the roots still live, and the roots still provide stability to slopes. Now, the one weakness of bamboo like this is that, and it's the same weakness, by the way, for wood, is that insects like this is a cellulosic material, so bugs like eating the sugar content that's in the cellulose. So the first thing you do when you cut down a length of bamboo is you throw it in boric acid. Now, what's boric acid? It's a very simple combination of borax, which is a natural substance, with water. You soak the pole in the water, for 24 hours, and that treats it. Okay, and then you're good to go.
So what are the decomposition properties of bamboo in lumber applications compared with wood?
Well, you can use bamboo for anything you use lumber for, like a beam or a column would be round instead of rectilinear. The connections are what I got involved in. My research was focused at the connections. How do you connect a bunch of cylinders? Here's a connector that I got a patent on. A pole goes in here, a pole goes in here, a pole goes in here. So this would be a very simple column and two beams. And then you wrap like a zip tie around these, and you squeeze the zip tie. It puts hoop compression around the bamboo, and then the bamboo cannot rotate and you can't pull it out.
Are there little teeth on the inside of the cylinder there? Like,
Well,
did you put grip, like some kind of gripping texture or friction texture?
Well, yeah, you could make the inside surface of this rough to enhance the friction. I mentioned one weakness of bamboo. Maybe I didn't. Its weakness is dry weather. So you're not going to see this stuff in a prolific way in the deserts like our community. But wherever there's reasonable humidity, you can use bamboo.
Can varnish or wax seal it?
Wood. And it turns out that 95% of the world's population lives within 100 miles of a coastline. That's the sufficient humidity.
Mm-hmm. Mm-hmm.
So wood is a little bit more supple, I'll call it, than bamboo. In bamboo, you cannot put a nail, you cannot put a screw, and you can't drill holes to put in bolts. You can do all those things with wood because it's like a supple material. Bamboo is extremely hard. So my connectors don't use screws, nails, or bolts. And throughout most of the Eastern cultures, they connect poles together with twine. They tie twine around these joints. The problem with twine is that it oxidizes, and when it rains, the ties get wet, they stretch, and then you lose your joint. So a lot of people have been killed falling off of bamboo scaffolding when it rains. So you need a sturdy connector. Okay, here's another connector that's for like an elbow.
What about industrial tapes, like say that strapping tape?
You could use tapes, but again, when the building flexes back and forth, this tape gets loosened.
So what's your strategy for that then?
My strategy is to use this.
So that won't loosen with movement.
This is, by the way, just a toy. This was made by a 3D printer.
Mm-hmm.
This is a toy. It's not real. Imagine a real joint. Bamboo can get as large as 12 to 14 inches in diameter in the Hunan province of China. So that's this big around. This simple connector, this distance from here to here, would be 6 or more feet. And this opening would be a foot, this cylinder.
And I was going to ask how consistent the bamboo sizes are. If I have a particular species, will a prefab connector like that consistently fit the diameter of it?
No, see, that's why I've designed this to be, it squeezes at the end. See these gaps?
Mm-hmm. See
these gaps right here? So when you put a zip tie or a hose clamp around the ends, you squeeze down, and this gap allows it to squeeze down on slightly different diameters. Now, here's the key. With lumber, the first thing we do with the tree is send it to a sawmill, thereby introducing even more CO2 into the process.
And throwing away quite a lot of the wood.
And throwing away quite a bit of it, and sawdust and whatever. These things are designed so that the diameters on each end of a pole, which you know is going to be slightly different, are still accommodated by a range of these. So let's say I want to go from a 4-inch diameter up to 12-inch diameter. I'd probably make 6 groups of these, 6 groups to accommodate that change in diameter. For a 10-foot pole, the difference in diameters is going to be about no more than 10%. And so this is accommodated by that. So you're asking some very good questions that I had to get into in my research. And also in describing this to the patent office, you know, how's this work and what are these things for?
Now, I was reading a little bit about lumber, engineered lumber from bamboo, but that seems to involve a lot of epoxies and the like that offset some of the sustainability and non-toxicity advantages of bamboo.
Yeah, you're
What were
referring
your,
to
yeah,
what's called glulam.
yeah, okay.
Glulam is laminated thin strips of lumber. There's thin strips of lumber that are laminated and stacked together on top of one another
A kind of plywood.
and glued to make specific forms. Like a glulam beam could be 8 inches wide and 18 inches deep. That's not a naturally sort of occurring unless you had a really large tree. But glulam is very expensive. But it turns out with bamboo, they can do the same thing from this from the perimeter of the bamboo, which is the strong part. You can take thin strips out of this, small lengths around the circumference, and do the same thing. You can lay laminates of bamboo up to make a rectangular shaped beam. And it's 3 times stronger than wood. But it's also very expensive because you're taking little laminates out of a curved perimeter instead of a chunk of wood, which would be already in a rectangular configuration.
There were a lot of mentions of bamboo having a compressive strength greater than that of concrete. Bamboo is a renewable resource. Concrete is not. Neither is beach sand, which is one of Toby's interests, by the way. But it decomposes, which concrete does not. I mean, Roman concrete is still around. Um, what are people? Are there avenues for bamboo to offset some of the use of concrete that's actually been changing the world resource
Of
picture?
course, it's got. When I say it's 3 times stronger than wood, it's 3 times stronger in bending. It's actually 7 times stronger in tension than wood. It's twice as strong in compression as wood. And no, concrete is stronger than wood and bamboo in compression. The problem with concrete is that you need reinforcing steel in it to capture all the strengths. And that introduces the weakness of reinforced concrete, which is when it cracks. It naturally cracks when it bends. Water gets into the cracks. In the winters, the water freezes and then expands and makes the cracks larger. And salts, either human applied salts or naturally occurring salts, especially near a coastline, they get in and corrode the steel. So does the water. So eventually, reinforced concrete, the steel corrodes and then the concrete column will collapse. The ancient forms that you saw were probably stones or silica, the ones you were calling concrete, that still exist. But if you look at them, they exist in dry climates, especially in around Egypt, for example, or anywhere in the Middle East. Dry weather helps materials last much, much longer than humid climates.
Although ironically not bamboo.
Well, yeah, bamboo performs best if it's in a moist climate, of course.
Yeah, interesting.
Same thing with wood. Wood cracks under dry weather, so does bamboo. So I'm not suggesting, hey, we're going to see a bunch of bamboo structures in New Mexico. No. But New Mexico is with 5% of the world that has populations living in the desert.
Right, right. Now, I had the sense that the large timber grade bamboos require equatorial climates, although of course that's moving further and further from the equator, but basically no freeze zones to grow. Is that correct? Or are there large
Well,
timber bamboos that
it's
can tolerate?
essentially correct.
Yeah.
Lumber grade bamboo, I think, was the term you used. But don't forget, one of the largest stands of bamboo in China is the only forest where panda bears exist. The giant panda. Whenever I give my talk on bamboo engineering, my first slide has a picture of a panda. And that just melts people's hearts. After that, you got them.
I say we make it a rule that wherever we grow bamboo in the U.S., we import pandas.
Yeah, but you're right. Most of the sort of building grade bamboo would be sort of equatorial, but there's a lot of land near the equator.
Mm-hmm.
And it's because of the amount of rain you need to grow bamboo. You know, it's not going to grow in an arid climate.
It also seems to be more tolerant of soils that might be insufficient for trees.
Yeah, I'm not sure about that. I do know that one of the advantages of bamboo is that bamboo leaves sequester 35% more CO2 from the environment than do tree leaves. And the root ball or root zone of the bamboo poles is that sequesters 25% more CO2 from the environment than do the roots of trees. So though, you know, that we should be planting lots and lots of bamboo, irrespective of whether we're going to farm it for building applications.
So the leaves, though, aren't preserved. So that CO2 is going to be returned to the environment. Maybe, though, they could be used for things like biofuels so that it's neutral at least. It returns to the environment only the CO2 it took out of the environment.
Well, I know that since it's a cellulosic material, that there's been a lot of work done on conversion of bamboo to, say, ethanol kinds of compounds, just like trees.
Yeah, or
And
sawgrass.
smaller things like corn and soybean and whatever. So a lot of advantages to bamboo, many advantages, environmental, and certainly in construction. The construction advantages, we just barely have taken advantage of that, barely. The homes that you see around the Pacific Islands, lots of bamboo homes, they're only 1 story tall and they're private residences. As structural engineers, we use building codes to ensure that the governments will okay our designs. You don't have to have the government okaying the design for a private residence. But these buildings are only 1 story, so your loads aren't nearly as high as they would be if you wanted to build a 5-story building. And I have submitted that bamboo can be used to support 4 to 5-story commercial buildings. Not higher than that. You won't see bamboo for skyscrapers. It's because of its flexibility.
I'm not sure if you see.
Its flexibility is an advantage in high winds or earthquakes. So it's got high flexibility and low mass, which is perfect for earthquakes and high winds. But it's also a detriment if you're going to make a real tall building and you don't want it swaying too much in winds because people get sick inside the buildings.
Well, that actually raises a couple of points. By the way, I don't know if you can see the same thing I am, but John McKinney is asking, what do you think about metal for your T connectors? Well, for your various connectors.
Yeah, yes, you could use. And by the way, my last research project is trying to find the right material for these. Yeah, you could use steel, but one of my goals has been to try and be in as close to a 0 CO2 mode as possible.
Mm-hmm.
So I'd like my connectors certainly to be as strong, maybe a little bit stronger than the bamboo itself, but I want to minimize the CO2 footprint used to construct them. It's a goal of mine. Steel has a very, very high CO2 footprint. So does reinforced concrete, making the cement additive. And then, of course, the reinforcing steel, very high CO2 footprint. Wood has a high CO2 footprint because of the sawmills we have to use, that we have to power, and also because of the waste with wood. And who wouldn't want to use the material that panda bears like? Bamboo leaves are the only diet material for pandas. 99% of a panda's diet is bamboo leaves, and 1% is protein. And the protein comes from the bugs who are on the leaves that the panda bear eats.
Yeah, it's amazing they can actually live on that.
Yeah, and John has asked about bronze or galvanized steel. Again, it's the same answer. You know, there's materials that are stronger and more ductile than bamboo, but I want something that's light and strong and near ZO2 in its manufacture, because it's my goal to try and make this whole idea very, very sustainable. And if you have to haul around steel or bronze connectors, you need big trucks to haul it around. And if you're hauling around bamboo poles and these light connectors, whatever the material is that I eventually wind up using, it's going to save a lot of money in the construction process.
It seems too like it would allow for
workers' backs who have to carry it.
Yeah, it seems too like it would allow for a lot of flexibility and ingenuity in the way that you put it together. It seems like it'd be easier to work with than, screws and nails and 2x4s and things like that. I've been doing a lot of that stuff lately, and this looks more like a Lego set to me.
Exactly, and you know what? On this thing, you can reuse these. We have, for example, in scaffolding, our scaffolding are steel connectors and steel poles. They can be reused, no problem, but it's very heavy. And it's very time consuming to put them up and take them down. But these things can be reused. So it's one of the advantages. It's like, you're right, it's like a Lego set, except the little poles in the Legos, they're all the same diameter.
Right, that's what I was asking about earlier. How consistent is a single species?
Some tolerance for changes in the diameter of a pole that's 10 or 12 or 16 feet long. It's amazing. I don't know if people have seen bamboo when it grows, but it's amazing how uniform the diameter is all the way through the height of the bamboo pole. It only changes right at the very base and at the very, very top. Between those zones, it's very uniform, close to being uniform, I should say, throughout most of its height.
So relatively less uniform from pole to pole, but very uniform along a single pole. Did I hear that correctly? Did I say that correctly?
Yeah, exactly.
Okay. Yeah. Now, you had mentioned that bamboo wasn't good for flexed shapes. Can you steam it or anything like that? It seems like using arches would add greatly to the strength of bamboo architecture.
Bamboo can be used in many kinds of curvilinear situations. The new race cars made in Germany, their steering wheels are made out of bamboo.
To save weight?
The way they curve the bamboo is they put it in a press under extremely high humid and high heat, and they leave it in there for like 24 hours. So you can change the shape of bamboo through a heat and compressive processes.
Yeah, same technique as bentwood rockers.
Yeah, a lot of the covers, like bumpers and covered hood covers and so forth in cars, they're made out of bamboo. Check out this company.
That's actually one of the questions I wanted to ask. What about bamboo fibers as cloth? What do we know about that?
Well, yeah, there are many, many sheets, as you know, that are made of bamboo, sheet
Yeah.
companies. And I don't have it on today, but I have a t-shirt that's made from bamboo, very comfortable. And it lasts much, much longer than cotton. Cotton fibers, eventually degrade, and bamboo fibers would as well, but it lasts
Takes
much longer
longer.
than cotton.
Now, presently, they're not cheaper than cotton, but I think if they were mass produced, they quickly would be.
Yeah, not too many products made from bamboo are less expensive than alternatives because it's a matter of economies of scale. And look around our little city of Albuquerque, it seems like there's a concrete batch plant or a steel fabrication plant every few square miles. Well, you're not going to find that with bamboo yet. In fact, in this dry climate, you won't find it at all. But around our coasts, especially southeast and the east coast and parts of the Midwest, you could have lots of bamboo manufacturing going on there. They get enough water to sustain growth of the bamboo grove.
Well, and they also, as you pointed out earlier, can stabilize areas of soil. I would think if you did something like polyphase farming with bamboo, some of the same underlying concepts, you might actually be able to expand the area where it could grow by having it improve the soil as it goes along.
Yeah, the big complaint I hear from lay people like my neighbors and so forth, and even from me, is if you plant bamboo in your yard, the root zone eventually takes over. And people complain vociferously about how they can't get rid of their bamboo.
Yeah, I know, which
Well,
seems like a virtue to me, right?
okay, it is invasive. And if you just want it to be confined in a certain area, you need to put in some little curbs around your growing area.
So fair enough. One criticism I can imagine of bamboo is that we could wind up replacing a lot of North American deciduous forests with bamboo forests because, people will chase the money in the economy. If this were adopted on a wide scale, what happens to our existing ecosystem?
Well, just go out and ask the pandas how they like the forest. Where the pandas exist, there's bamboo with uh, other trees and bushes. It's not just bamboo. And
So
yet,
is bamboo a relatively good neighbor from the standpoint of other plants being able to grow around it? Like creosote kills everything around itself, for example.
well, I've
Trees
never
crowd
heard of
stuff
that.
out.
I've never heard of bamboo other than its invasive nature when it grows. The root zone is invasive, and it can crowd out um, crops or bushes or trees that are next to it. Yes, but there is a symbiosis, say, between the varieties of leaves of different plants and those of bamboo, and it's a product that grows in clumps. Have you ever seen a bamboo clump? It's like about, I don't know, 20 or 30 poles in there. And another thing I should point out is a lot of people like to use bamboo because it grows so fast as a wind block and sometimes as a visual block. And the thing I like about bamboo, since I'm originally from the West, is it's an evergreen. It does shed its leaves, but even in the winter, they're green. It's like have you heard of the tree larch? Larch is considered a deciduous tree, I think, but it's green all year round.
So what do you think happens between here and the future? How does bamboo get more widely adapted, and what will be some of its limitations?
Well, in the presentations I give, I think that the one biggest roadblock to the use of bamboo in the Western cultures, I call it the Western cultures, is culture. Think about it. Why do people like wood? It's a human thing because we then control the shapes and the connections. Since wood is in rectilinear shapes, our connectors are rectilinear, and it's very easy to make rectilinear shapes. They're flat, then you bend them in right angles, and you're done. So we, being the Western cultures, I think, this is my opinion, we like to control things. We want
Yes.
control. The Eastern cultures are more accepting of nature. And there's one thing about bamboo you cannot deny. It's a natural, well, it's natural, but it's a product of nature. And if we want to use it, we have to accommodate the curvilinear geometry of bamboo. It's round. So we have to make round connectors. Those are much more difficult than rectilinear connectors. It's not easy. Try and make a drawing with your hand of the connection of two poles, say at right angles. Here comes a pole, here comes a pole. Or draw the connection, the geometry of the connection of two cylindrical poles like this. It's very difficult to draw. If these are all rectangles, it's very easy to draw. They're all straight lines. And so the manufacturing process, I think, is 3D printing, first of all, is way too slow. I mean, this little piece took 5 hours. The piece I have lost, which showed 6 poles coming together in an internal joint of a building, 2 columns, and 2 sets of orthogonal beams, that took 20 hours for a little toy. 20
Well,
hours.
I'd imagine injection molding and done at scale.
Exactly. Injection molding or some kind of a mold process where we pour the material in as a slurry, and then when the pieces are done, we join them together by a very, very high strength epoxy glue.
Well, now, if you're thinking along those lines, what about creating a mold that you actually clamp onto the bamboo joint, the 2 or 3 piece bamboo joint, pour the stuff in there and set it
Well,
in
you
place?
could do that. You could do that. My idea
Wouldn't
for
be
a mold
reusable, though.
would be something made of steel so you could reuse it hundreds and thousands of times. You don't want to make your molds all the time. You want them to be made one
No, I
time.
was imagining a mold you would then pull off afterward. But
Yeah, like
another
a
way that you
blanket.
could do it would
Like a
be
blanket.
paper molds made of that sort of paper mache that's used as padding in a lot of boxes these days.
Yeah.
So you could assemble your bamboo pieces, put the paper mold on them, pour your material in there, and after it sets up, who cares if the paper falls off?
It's an idea. You should file for a patent.
No, you can have the patent.
No, there's once new industries open up, there's going to be all kinds of new ideas.
Yeah.
But my little dream is, now that I'm an emeritus faculty member and I don't have to teach very much, and I can do research on what I want. And all of this, by the way, is for zero pay. That's what emeritus means. It means
Yeah.
zero pay.
Yeah, I know.
You know what I'm talking about. But I have this dream that I could make one of the very first bamboo connector company, manufacturing plant here in New Mexico. Because it doesn't matter where you are when you're making the connectors. We're not going to use the connectors here, but we could make millions of them here. Right?
Well, one thing I'd say to the
Why
people
not?
listening is that if you look up bamboo designs and bamboo architectures, and you see some really, really beautiful stuff.
Oh,
But,
yeah.
like you said, we're pretty dialed into things like drywall, flat, smooth walls that we can hang pictures on, which you can on a bamboo wall, too. I saw it many times in the Philippines and in Asia, But yeah, I would just recommend to people to look at what's been done with bamboo and see how beautiful it can be and how varied compared to the uniformity of the way that we tend to build things right now here in this country for reasons of scale and also habit.
Yeah. No, there's some very beautiful structures that some very clever architects have designed around the world. There's this music auditorium for outdoor concerts. It's in Germany. Just gorgeous, especially at night when the light hits this structure. Very beautiful structures. And there have been structures that used connectors that are extremely expensive and novel. like you take a bamboo pole and you take the little diaphragms out. You take these diaphragms out here, take them out, and then you, at the ends, you fill it up with concrete or something. Then you embed a bolt in there. And then on the end of that bolt, on the end of the pole, you put a steel plate, and then other bolts emanate from that plate that then go inside of other bamboo poles. I mean, really, I'll call it exorbitant ideas for joints that would be extremely expensive. You know, you'd never want those in a building because you wouldn't be able to sell the building because of the cost. But if it's an architectural enterprise where you're trying to, you know, captivate people's impressions about the beauty and the form, you don't care so much about the money. You know, you're looking for the aesthetics and the wow factor.
Now, as an engineer, how do you feel about the non-uniformity of a naturally growing material like this?
Well, I'm a product of Western culture, so I have to admit that it's very difficult working with cylinders and things that are round. But I'm also a convert to the Eastern cultures that they're relaxed about this. Well, whatever nature has provided you, try to use it in its natural state and don't fight this thing.
I'm thinking more in terms of, for example, mechanical engineering is so sophisticated now that a lot of times, once it prototypes well on a computer model, they skip prototyping and go right to manufacturing. But with natural materials, you have to account for internal voids and gaps and weak spots and differences in from one point to another. You don't get that same uniformity that you do with injection molded plastic or forged steel or something.
Right, but remember, I go by two things. Well, first of all, I'm not doing anything with the bamboo. I'm taking it as nature gives it to me. And yes, there are flaws, but we know how to capture the reduction in strength properties through these flaws. We do that with wood. Wood's got knots in it. You know what knots are?
Yeah.
Yeah, and steels have bubbles in them, and reinforced concrete has got different size aggregate in it. I mean, everything's got flaws.
So, in other words, this is consistent with the engineering we're doing now at the architectural scales.
When you mention mechanical engineers, they're actually making materials that are not flawless, but reductions in flaws, like some of these plastics and polymers. But it's very expensive, number one. And number two, very, very high CO2 footprint. I mean, we can't just think about oil and gas and its effect on CO2. We got to think of everything. Almost everything we do that's an industrial process produces CO2. And so we need to start reductions in everything that we can.
We're right at 45 minutes now.
Okay.
But what do you think I should have asked that I didn't think to ask tonight? What would you like to make sure people hear about bamboo that I didn't get to?
Well, I think you've raised many of the points. You ask a lot more questions than I normally get in a seminar. Maybe because you're in medicine and most of my audiences are engineers. I'm just saying, you know, just think outside the box. Bamboo is going to be available to you in more than just your carving boards and your spoons and ladles and your little dishes like this one for jelly beans and so forth. Just think outside the box, and just in the parties you go to, just start talking up bamboo. It's a natural substance that's underutilized in the world. Not so much in the East, but certainly in the Western cultures, in the United States, all through Europe, all through Central Asia. You know, you really don't start hearing about bamboo unless you're in the equatorial regions. That's right.
Well, a really good way to stimulate people's imaginations, I found when I was prepping for this, is to simply do a Google search under bamboo products and just look at the enormous range of things people have done. Now, some of them were these engineered materials that I think sort of miss the point. I'm more on the page you're talking about where you use bamboo for what it is rather than trying to rejigger it into something like a square timber or things of that sort.
Mm-hmm.
But that will be on the list of things you'll see if you do a search under bamboo products. You'll get a idea of the enormous range of applications people have found.
Yeah.
And I think there will only be more as people get more interested.
Well, just think about our forests. In Canada and the United States, we used to be large exporters in lumber. We're not that anymore. In fact, there's shortages in lumber. We got to think of some replacement materials. And
Well,
not
we
just
never.
ones you can grow in a laboratory like the mechanical engineers. How about growing naturally? Let's just plant more bamboo in the forests, especially on steep slopes near highways.
Where it can much more rapidly stabilize those slopes than lumber
Yes,
could.
yes.
Well, foresters have traditionally been farmers who harvest but do not sow. Then in the 60s and 70s, rules began to come in and they began to plant trees where they had harvested. But when you hear, things like there's more trees now than when Columbus got here, they're counting saplings that are a foot tall as trees. Um, and also, a tree orchard is not a forest. Now, I'm going to have the same concern about bamboo. Bamboo farms are also not forests. So we're not replenishing forest, but if we're harvesting bamboo, we're using fewer acres to get the same amount of usable lumber and potentially leaving more opportunity for forests to re-mature.
Yeah, well, again, keep in mind that to grow a tree that you can use for serious structural application takes anywhere from 85 to 95 years. It's a long time to wait. Even with replanting programs in place, which we have, and so does Canada, we're using it faster than the replenishment rate.
Far faster.
Yeah. And again, with wood, you waste about 30% of it. You don't use the limbs so much. You have to deal with the knots. Those are the imperfections in the wood, which we can accommodate. We have strength reduction for knots when we do our designs. And again, you're not going to see these on the highways going through the West where it's dry. You're going to be seeing bamboo, I hope, along the highways and the steep slopes where it rains.
Actually, the biggest ones might be useful as telephone poles. Also, we've talked a lot about the non-uniformity of the shape of bamboo, but the thick-walled ones, it seems like you could lathe pretty readily into, pretty perfect cylinders with much less waste than you would with wood doing the same thing.
Yes, but
and
your
much
poles
less
would
power.
be short. They'd be short. You wouldn't have one 16 feet long on a
Oh,
lathe.
really? I'm surprised to hear that because I had thought timber bamboos hit like 30 to 70 feet.
Oh, yeah, yes, but the diameter changes in that length.
Okay, I see.
Yeah, now, by
John,
the way, there's a lot of details that I didn't go over. See these diaphragms here that provide strength and stability to a pole to buckle? These also get in the way of things like coating the inside surface with your boric acid. But to do that, you just drill a 1-inch diameter hole through all of these. You still have the strength capacity of the diaphragms, and you still have boric acid that will go through and coat the insides.
Could also run
a hole
plumbing
through
and
the
electrical.
middle is where you could put cables. If you're using it for buildings, you need to have communications cables, electrical cables, and water and sewer. Okay. Now remember, this is only 5-inch diameter pole. Bamboo grows up to 14 inches in diameter in Hunan, China. In Brazil, you get routinely 8 and 9-inch diameter. In Brazil, they don't have the really super big stuff there.
Well, it sounds like we need to get the lumber industry interested in bamboo as a supplementary.
Well, it's funny. I approached the lumber industry as potential investors. And I approached them when I was first trying to get a patent on this. It was like I had a horrible disease. They ushered me out of their facility real quick. They know about bamboo. Okay. Remember when rayon came out? I don't know if you know the history about what was the guy's name? DuPont.
Yeah, and it started as a
You
synthetic
know how the
protein.
DuPont
Actually,
and his buddies in Congress, do you know how they cleared the way for rayon to succeed? They tied hemp. Hemp was the leader in stockings and various kinds of clothing and lines and ropes. They cleared the way out by tying hemp to marijuana. And then they
oh,
put marijuana on Schedule 1. There goes hemp. Hemp had to go underground, just recently came up for air. And DuPont took off. That could happen with bamboo. There's a huge industry, and it's powerful in wood. So if you're in the audience and you're an attorney, this would be a good cause for you. Jump on this one.
so let's start spreading the rumor that smoking bamboo will get you high.
Yeah,
So
you
John
use
wanted to
bamboo
know
instead of wood is going to put a lot of people in
if
a
there
tough
was any
spot.
benefit to making telescoping sections of bamboo by punching out some of the diaphragms. I don't know. Is that a building technique that's got a lot of utility? Or
Well, I hadn't thought about it, but you did. So again, I think that's a patentable idea.
John did, not me. That came from our one of our
Okay.
viewers. Yeah.
Yeah, I mean, you know, it's just it's a new industry. There's so many new things that can be done. Think about this. If you can construct the frame of a building, which is the thing that supports the loads, what are you going to do about the walls and the floors and the doors? Okay. Are those also going to be wood? Bamboo? They can be. You can have
Well,
you can have bamboo planks by cutting out little laminated sections out and gluing them together. But there's going to be new industries spawning up that create the secondary elements. Once you've got a structural frame that supports the loads, you have to put things on there like walls and floors.
yeah, you're stopping short of saying it
Windows
quite
and
this way,
doors.
but
There's going to be a whole bunch of new products that come out, not necessarily made of bamboo. It could be made of wood or other light materials, light but strong, plastics that fit the bamboo frame.
so we're
Lots
talking
of new
hybrid
products.
constructions here.
Yes,
Most of the inner structures in a building are not load bearing. So you could use traditional sort of American construction for the
that's
big
right.
load bearing components of a skyscraper, but you
Exactly.
could still
Look
build a
how
lot
they
of the
make
internal walls
manufactured homes.
using bamboo.
Manufactured homes are made of a variety of these new materials involving plastics, for example. They do have an aluminum frame that takes the loads, but the walls
Yeah.
and ceilings and floors, and of course the windows and doors, can be made of all kinds of different materials. It doesn't have to be bamboo.
Well, it
What
happens.
I'm proposing is that bamboo is a very strong, based on weight, material. Did you know that the ratio of the strength, the tensile strength divided by the weight, okay, that's a ratio, tensile strength divided by weight, of bamboo is 7 times that of steel.
I had read that and
Yeah.
meant to ask you about
And
it.
when we buy construction materials, we buy them according to weight. Now, if you could get 7 times the strength of something, of steel, and be 1/10 the cost, you're going to do it. That's
So
economics that makes sense.
it'll take a little trial and error to find the best applications, but the more people are aware of the versatility of bamboo, the quicker people will start to solve these things, to start finding best uses for it.
Yes.
And, I'm a fan of it simply because for me, one of the biggest draws of it is its very rapid growth and its comparatively slight cultivation requirements.
Yeah, the number of applications for bamboo is going to be enormous. It just requires a little bit of thinking outside the box.
Well, I learned a ton tonight. Thank you so much, Dr. Ross.
Well,
I wasn't kidding. I'm hoping we get to talk to you about other topics in the future as well.
well, certainly just let me know. I'm around, although this next month I'm going to be traveling up in Spokane, and then I spend my winters in Mexico.
Nice.
But everywhere I go, I've got email and a phone. Like right now, we can see each other and hear each other, but we're not. I could be in Mexico right now. I'm teaching a class this fall to some graduate students, and it's not an engineering class. Well, I'm going to teach it from Mexico.
I was amazed by the range of classes on your CV. I think we have to be quiet now so he can walk us out.
Yeah, I've been more of a generalist than a very specific. Most faculty are just experts in a tiny area, but they're really, really experts. I've gotten into like 5 or 6 different technologies. So it's nice to meet all of you.
What's New in Health and Medicine with Dr. Coffee Brown, video and podcast is produced by Shelley Carney and Toby Eunice from the AGK Media Studio in the Land of Enchantment. Please take a moment now to subscribe and leave a great review. Then share this podcast with your family and friends so they can help heal the planet and improve their health too. Thanks for listening.